Thanks everyone for coming out to the June PyData meeting. We've Joe Wolfe joining us from Capital One to demonstrate standardizing the model development and approval process with Rubicon-ml. Special thanks to our sponsors, Capital One, MetroStar, Spell, NVIDIA, and NumFocus. So the goal for our PyData DC meetings are to foster an open and inclusive community for people of all backgrounds and experience levels. So feel free if you have questions, speak up either in the chat or however Joe mentions he'll be, fielding questions. And after our talk, we'll open up the floor for a virtual happy hour. So if you're interested in staying for that, we will have the opportunity for everyone to casually talk afterwards. We are recording the meeting, so if you'd like to, leave your camera on, great. If you want to shut it off, go for it. We'll have these posted to YouTube later. So if there are also some older PyData meetings that you'd like to go back and watch, we'll have those present there. So with that, I'm going to go ahead and hand this off to Joe to get started.
All right, thank you. Let me just share my screen. All right, look good? Can you see it? All right, sweet. Okay, so hey everybody, welcome to standardizing the model development process with Rubicon-ml. So just quick intro on the team. As Wilson said, I'm Joe Wolfe. I'm a senior software engineer at Capital One. I'm in the Center for Machine Learning organization on a team called ML Tools. And as the name suggests, we work heavily in the ML space, building tools for that ecosystem. Also, I believe on the call is Sri and Mike, and they help lead the efforts in that organization as well. Okay, I guess to start, just to give you an overview of what we're going to do here, I'm going to talk through how Rubicon-ml came to be within Capital One and the latest version of it. And then I'm going to demo, starting with the documentation to a quick overview of how you could leverage it. And then I'll talk through some of the integrations that it offers. And then at the end, we can just open it up for questions. But if you have questions during it, just feel free to just unmute and ask. Okay, so as I mentioned, Rubicon started internally. Originally, it was a web application. This new version was something that came at a later point, but originally it started because of these questions. So we heard a bunch of our data scientists and ML engineers ask how they should track their model experimentation over time, how they could view the data that they've been collecting and explore it later on, how they should be visualizing this to draw insights, and then specifically, like within Capital One, how to go about the model review process. So how do they share their work with collaborators or with the model reviewers, and then how do they ultimately end up getting their model approved? So these questions led us to develop Rubicon, and fast forward till today, we now have this Python library that we've recently open sourced. And just to break it down, there's a couple different components of it, but one piece is the logging aspect. So Rubicon has a lightweight Python library that lets you track experiment data over time in a repeatable and searchable way. That's the logging aspect. And then it also comes with a dashboard that you can use to visualize and filter your experiment data. And that's built on top of Dash, and it runs in the browser or in Jupyter Lab. And then it comes with a collaboration process, and that lets you share a subset of your data with whoever you really want. And the key points here, it's reproducible because, as you know, within this model development space, you need to have full reproducibility of your model runs. And it's extensible, meaning it integrates well within the Python ecosystem. So it was designed to be able to be plugged into the existing libraries that are heavily used, And I'll talk about that later on. And then last, it also has like built-in asynchronous support. So that is the quick look. So I'm going to jump to the actual docs and just give you a quick overview of the glossary, just to get the terminology straight. So with Rubicon, the top level is a project, and a project is basically just a collection of experiments where each experiment represents a model run. And then experiments hold your inputs and your outputs. So your parameters and features would be your inputs, your outputs would be your metrics. And then additionally, we also have data frame and artifact support. So data frames can be logged to experiments or projects. We support pandas or gas data frames, and often they're used to represent complex metrics that don't really fit in the regular metric class. So one example you see here is the confusion matrix logged as a pandas data frame, and that's tied to an experiment here. And then, sorry if you hear my dogs barking. And then the last piece is an artifact, and that's a catch-all. So you could use that to really log any type of data that would be relevant. So one example would be like the pickled model file. And then talking about install steps. So you can install Rubiconml through Conda or through pip. If you install through pip, you also have to install additional extras for some of the different components that we talked about. Okay, so then I'm going to go through the quick look, but I have it running in Jupyter Lab. So I'm just going to run through this, and that we can work through it together. So is this blown up enough? Can you see the text, or do you want me to zoom in a little further? Thumbs up if it looks good. Okay. So in this example, we're just going to train a simple classification model, and it just comes straight from scikit-learn docs. So this first piece here is just bringing in the relevant data and setting up our test and train. And then this is the Rubicon piece. So to start, like one of those key pieces that I mentioned is the logging library. And right now, Rubicon-ml supports logging to memory for just experimental testing. And then it supports local or S3. And the key thing to note here is it's built on top of FSspec, which is an open source file system specification. And the way that Rubicon is designed, any underlying file system that FSspec supports, Rubicon could also support. Just right now, it's local and S3 because they met our needs. So we could take a look at this first cell, and this is setting up the top level Rubicon object. And so here we're just setting up our root directory, and we're saying our persistence is to the file system. So I'm basically just saying I'm going to log locally to my local file system at this path. And then I'm going to create a project there. So if I run that and I refresh, you can see I now have this Rubicon root folder, and this will hold all the metadata about my experimentation. So then this cell kind of bunches together all of the Rubicon methods just into one function to show how you can integrate it into your code. And so starting, we pass a Rubicon project in, and we're logging an experiment. And then, we're going to track some parameters, some features about the wine set. And then here we are making our classifier, using make pipeline from scikit-learn. And then we're fitting the model, predicting, and then we're going to store our accuracy as a metric here. And then just to show extra functionality, we are also tagging a confusion matrix, and then we're tagging the experiment. So tags are a good way to basically filter your data later on. And so just for the simple use case, we say if the accuracy is greater than or equal to 90%, we're going to tag it as a successful experiment. So now I'll just run this a couple times, basically like replicating a quick little grid search just across a parameter set. And if I look at this folder, we have our project, and then we have a bunch of experiments under here that all have their corresponding metadata. Okay. And then just to note, if you wanted to switch it to S3, like for collaboration or backup, it's as simple as just either syncing your project from local to S3 or just using an S3 path when you're logging your data. Okay. So that's the logging aspect. The second aspect that we talked about was the dashboard. So I'm going to start this and hop over here. So you can see I have my wine classification project. I have one set of experiment runs with 14 experiments with the model name set. And then that drops down and I can see all of my experiments, and I can sort, I can filter this data. I could sort to right off the bat find the highest accuracy. And let's see about that. And I can select my data and visualize it. So this plot right now looks pretty simple, just because there's not a lot of parameters in here. But you could imagine, you're training something that has a bunch of parameters. This will really help draw those insights. So this is customizable. You can move things around. You can select a subset of the metric that you want to see, and it will highlight the trends for you. And you can also deselect different parameters to kind of limit the amount of data that you're viewing, and make that process a little easier, and it will adjust for you. So that, and then you could also set, if you had different metrics that you're trying to compare, you could set them here, and this would adjust. So that's the dashboard. And then the last piece that we talked about was that publishing and sharing process. So that was for collaboration. So basically, at the end of this process, data scientists have a collection of all their experiments, and they're ready to share this result for model approval. But they need to, paint the full picture, but maybe they don't need all of the data. So this process lets them go through and select a subset of experiments that can paint that whole picture, and create a catalog file that can be passed around and consumed by the model reviewers or these collaborators. And the important thing to note with this process is it doesn't actually move the data around. It just references it. So you could put your data in S3 and then just set up your permissions for the reviewers and collaborators. And as long as they have access to the bucket, they could consume your experiment data using the file. So let me go ahead and run this. So in this example, I'm using the Rubicon.publish method to publish all experiments that are tagged with success. And I'm writing it to an output wine catalog YAML file. And just a note, this is built on top of intake. So if I print this out, you can see we have our data, and then I can consume this. And here I read the catalog and I got my experiment data back. Delete that. So that's the quick look. I guess I could stop see if anybody has any questions before we jump to the other pieces, those other integrations. We could just also jump directly to that. I'll just give a second in case anyone wants to ask something.
Yeah, I love being able to see the visualization on some of the parameter tuning in the dashboard.
You would like to see more of that, or?
No, I was saying it was awesome to see that.
Oh, yeah. Thank you. Thanks. Yeah, so one thing we also added is binder on the README. So if you wanted to get spun up quickly, you could do that. So I'm going to let this get spun up while I talk about some of the other integrations. So yeah, right now we have 3 main integrations, one with Git, one with Prefect, and one with scikit-learn. I'm going to go over the Git integration and the scikit-learn integration. I might just run this locally because this might take a little bit. Let's see. Just keep checking on that. So for the Git integration, basically the point of this is the model approval process needs to be auditable. And so every single, experiment needs to be tied directly to the model code that produced it. And to make this super easy, we could just support integration with Git. And if the data scientist or model developer is using a proper Git workflow, all of their experiments would be tracked with the branch and commit history automatically, so that they don't really have to do anything. It's all taken care of for them. And to turn this feature on, all you do is set the auto get enabled flag to true when you instantiate the top level Rubicon instance. And as the docs here show, if you're in a proper Git repo, you'll just have access to all that data. So including the branch name and the commit hash. And I want to show you this example if it starts up. It's taking a little bit, so let me just run it locally. I guess another thing to call out is Rubicon-ml comes with a CLI, and I'm using that right now to spin up the UI and read some local data. Oh, it's already introduced. Oh, because I didn't stop it from Jupyter. Stop that. Once again. Okay, so this piece shows our different experimentation over time. And you can see here that the commits are directly linked within this dashboard, right? So you can see we tried 3 different models. Well, 2 different models, different iterations of these models here. And, we could explore the data. And then if we wanted to, we could jump directly to the model code. And, okay, I'll show this example because everybody can access this. It's classifying penguins. I thought that was funny. So yeah, so if I wanted to jump to the model code, I can, and then, I could look directly at the model and see exactly what was imported and what's going on here, and I could reproduce this pretty easily. So that is the power of the Git integration. And also talk about the integration with scikit-learn. And so, one second. So our data scientists were pretty heavy users of scikit-learn. So one nice integration for them was to just support automatic Rubicon logging if they're using a scikit-learn pipeline. And so just to run through this example, we're going to show you how we expose a Rubicon pipeline, and you can basically use the same workflow that you were using with scikit-learn, but also just automatically track your experimentation. So normally you would import a pipeline from scikit-learn pipeline. Here you're just using our Rubicon pipeline, and everything is the same as before, except this time you're just passing a project. So this is the Rubicon project, and then these are the estimators. So this is my pipeline. And then, this is just a simple example of that running. But to get to something more realistic, using grid search, we could take a look at this example. So down here, we do the same thing. We import the Rubicon pipeline, and we also have this filter estimator logger that does exactly what it sounds like. It lets you filter the data that you're going to log. Since not all of it may be relevant, there might be stuff that you just want to filter out immediately so that you won't bloat your experimentation or your dashboard. And so this process, pretty much the same thing as above. You just pass your Rubicon project, and then you have your steps, and then you could pass your user-defined loggers. And so for this example, you'd see like we're selecting one here. For the TF-IDF, we are just ignoring everything, just saying we don't care about it. And then for the third piece, we are just taking a collection of 3 of them. And then we create our parameter set, and we could run grid search. And then all of this data would be just logged for you automatically and visible within the dashboard. So yeah, that's really the main power of Rubicon-ml. It's just very extensible and pluggable within these existing tools. And you can integrate it wherever you see fit and kind of get all of your model experimentation in the same place. So I think that's really all I wanted to cover. There's also an integration with Prefect if you're using that for your workflows. And all that's involved there is just importing the Rubicon Prefect work tasks and plugging them into your workflow as appropriate. Yeah. And I think that about wraps it up. I know we're a little early on time, but do we have any questions? I'm gonna drop this link in the chat.
Thank you. Thank you for the great presentation. Can you talk a little bit more sort of in general about best practices or easy pitfalls to run into when using Rubicon-ml specifically and in the sort of general like experiment tracking space?
Yeah, that's a good question. So I think one of the first pitfalls is not using the Git integration, because we've seen a lot of use that doesn't tie the code directly. I mean, it doesn't tie the experimentation directly to code. And that is crucial for the review process. So it's really important that that gets done right. Plus it helps organize the data. So I think the first thing to do would be use that Git integration and think about, how the model development process should go in terms of that tweaking specific models or comparing models.
Makes sense. Thank you.
So Joe, I have just a broad question about scale. What's your sense of when this starts, hitting some level of difficulty for the number of components in an experiment log, like especially long running or experiment with a lot of inputs and outputs?
Yeah, that's also a good question. We did do some benchmarking. I don't have the numbers like right now, but it does perform pretty well for most use cases. And since we support asynchronous logging, there's no blocking there. It's not going to slow down any process, but it does, if you are logging a ton of parameters, features, and metrics over a course of hundreds of thousands of experiments, then you could see that it could easily become a problem since it's leveraging the file system or S3. So I guess that is another pitfall to be, aware of what you're testing and what you're logging and why.
Yeah, and as a follow-up, have you guys, because it's using file system native stuff, what happens if you're dealing with like an encrypted file system or attempting to sort of encrypt some of the model components?
Yeah, that's a good question. I haven't dove deep into that. Could you be more specific? Like what pieces would you want to?
Yeah, well, I guess just within Cap One, I'm assuming you guys don't want, you've got your Gits locked down with role-based access control and stuff like that. So the components where these are and the file systems that the Rubicon components or the model components, are being orchestrated through Rubicon and where they live is encrypted. Like internally for you guys, is that pretty solid in terms of as long as no one can access the file system and no one can access sort of the tools that are orchestrating it, you guys feel good? Is there any concern about as it's sort of moving across the pipe? We have some partners that would love to use tools like this out of the open source, but they would probably want to do a lot of like encryption on the disk and other things for some of these models.
Yeah, that's a good question. Right now it's basically up to our users to manage that and, to like lock down access to the file system or to S3 as appropriate.
Okay, that makes sense. Thanks, man.
Hi, I'm George. I saw, when you're reading the data, it's plugged into an intake catalog. So for like, if you wanted to rerun the experiments, it's just, you have like a intake server somewhere and then that just manages where to get the data. Yeah,
it's just creating a YAML catalog file that has a reference to the data. So, if it's in S3, you would just have a path to where it's located in S3, and you could pass that to whoever has access or needs to review it. And then if they have access to that S3 bucket, it's just pulling that down and consuming it. And then, it's spitting it out back to you as Rubicon objects, right?
Yeah, it makes sense.
Cool. Yeah, so like a common workflow there is to just pass the catalog file to somebody, have them pull it down, and then spin up the dashboard to visualize the experiments.
Yeah, that's cool. Thanks.
Can you compare Rubicon to some of the other packages that are in this space, like MLflow, compare and contrast? Like, why did you guys want to build a new thing from scratch?
Yeah, so that's a good question, and I do hear that a lot. So as I mentioned in the beginning, Rubicon itself has been an internal product within Capital One for a while now. Started as a web application and was centrally managed. And then we slowly adopted Rubicon-ml because we wanted to integrate more with the Python ecosystem. So these things like the prefect and the scikit-learn integration really helped our data scientists versus the product that we had before. And to compare that with MLflow, that's not as extensible as Rubicon-ml, and it's not as pluggable into this ecosystem. So if you looked deeper into Rubicon-ml, you'd see it's basically powered by a lot of open source tools, right? So like the file system is off of FS-spec. We use intake for that collaboration process, and the dashboard is built on top of Dash. And then, all those integrations are just extra pieces that our data scientists commonly leverage. So I guess to answer your question, it would mainly be it's not tied to like an enterprise solution, and it's tailored specifically to data scientists using like the tools within the Python ecosystem, powered by open source.
Thank you.
It's good questions. Yes, so if we don't have any more questions, I guess the other thing that I wanted to mention is, if you take a look at this later today or tomorrow or over the weekend, and you see something you want to discuss, just feel free to put up an issue on the repo. We are like actively monitoring that, and we could engage in some sort of discussion about that. And if you see a feature or an integration that you would really like in this, definitely go ahead and put that up there. We would appreciate that.
Yeah, I guess as a addendum to that, Joe, I mean, like, how many folks are kind of working on this in the Cap One system? Is this like kind of a passion project that's slowly being adopted? Is this pretty much rolled out and there's lots of developers supporting it?
In terms of the developers supporting it, that goes back to that initial team slide I showed in the beginning. It's a smallish team of developers within, our Center for Machine Learning division, but it is being actively supported and worked on, and it is integrated into a bunch of different tools within the Center for Machine Learning division.
Okay. And Cap One and the machine learning folks kind of providing a lot of the current feature requests and stuff like that? Is that where a lot of the iteration comes from?
That's what guided us to initially create this version and to spit out the integrations that we currently support. So now that we kind of have those locked down, we're kind of in a holding pattern for more feedback.
Okay, cool.
And to switch topics a little bit, are there any, or what are you most excited about outside of Rubicon-ml, which would obviously be your answer, but what are you second most excited about in the sort of like ML operations space?
Oh, that's a good question. I'm not sure how to answer that. Like my background is not specifically in ML. So I'm more passionate about building these tools. And I think just for me personally, it's been working with some of the Dash components and building dashboards for more specific use cases. So like one thing I could picture with Rubicon is building dashboards specific to like the different types of experimentation that you could be logging. So right now it's very tailored to like your model experimentation, but maybe there could be a dashboard that's more tailored to model monitoring or something like that. If we kind of change scope a little bit there. So that's where my head's at right now.
Makes sense. Thank you.
So I see a question about using this information with management, or is it limited to the tech side? So that goes back to using this for like the model approval process. So the dashboard is, designed to be consumable by anybody. So yeah, it doesn't just have to be on the tech side. It can be any model reviewer or collaborator who needs to see the data